now we will do some question as a practice. You can say this is example number 1. So a crane is used to raise a block of mass 2 tons to a height of 75 meters in 45 seconds. So what is the average power output of the motor of that crane? Okay, so mathematically this is a block whose mass is 2 tons. We know 1 ton is 1000 kilograms, so the mass must be in kilograms in SI system of units. So it will be 2 times 1000. So 2000 kilogram is the block, which is raised to a height of, is brought to this position by the crane by putting some force in this direction. Okay, it is raised from point A to point B, which is at a height of 75 meters. So this gap is 75 meters, and it took 45 seconds to do this work. So we know that it is the work done against gravity. So because this force which the crane is applying, that will be equal to the work which is done against the gravity, the weight of the object times the distance moved. So power will be equal to work done by the driving force divided by the time taken. So work done by the driving force is equal to force, and force to bring it with a constant speed to this level B. If let's say that the force is F, or force will be better to take it as D. So this force is D which is applied, so it will be D times 75. Now what is D? D is actually equal to the weight of the object. So since we take G is equal to 10 meters per second square, so the weight will be equal to 2000, so 20,000 Newton. So it means that the D is equal to 20,000 Newton. First going with a constant speed upwards. The forward force is equal to the backward force. So it means that the work done by the driving force will be 2000 multiplied by 75, which is 150, and then 4 zeros, so this much, okay, joule. So therefore the power will be equal to work done by the driving force, which is 1.5 million joule, or 5 zeros, divided by the time taken 45. So then we will simplify this. It will be 45. So 3003, if we write exact value, so it will be 100,000 divided by 3, which is equivalent to 33333.3 reoccurring. So in 3 significant figures, it will be 33300, and it will be watt. So this is the work done, this is the power developed by the motor of the crane to do this work. We divide this by 1000, so it will be 33.3 kilowatts, because 1000 watt is equal to 1 kilowatt. Okay, So this is a better answer, 3SF, in finding the powers. So a mountaineer and her pack have mass 90 kilogram. She climbs a 1200 meters distant mountain in 160 minutes. At what average power is she working? So we have to find the power divided by her to do this work. So the distance covered is 1200 meters and the time taken is 160 minutes, which means we convert this into second, SI system of unit. So we multiplied by 60, these many seconds. Okay, and then the average power we have to find. So power, we know it is work done by the driving force divided by the time taken. So she is climbing 1200 meters. So it means if we assume that she is doing this work with a constant speed, because if you don't consider it as a constant speed, then some more information must be provided in the question, that by what speed she is changing, what rate of the change of speed, like the acceleration is there. So we assume that it is going with a uniform speed. Okay, so it means that she is working against the gravity. So it means that the driving force will be equal to the. So now it is equal to work done by the driving force is force times the driving force times the distance moved divided by the time taken. This much. So then we will calculate this. 900 times 1200 divided by 160 and 60. So it is exact 112.8. So it will be in watt. So this is the power which is divided by her to do this work in 160 minutes. Because the time is long, duration is long, so that's why we can say that smaller power is used. Okay, so or we can write to 3SF. Actually it is exact, so no need to change to three significant figures. You can also write 113 watts. Okay, so now we will see another question where so a car of mass 950 kilogram moves along a horizontal road with its engine working at a rate of 25 kilowatt. So the rate is the power. Okay. So working at the rate means power. So power is 25 kilowatt, which means it is times 1000, which means 25,000 watts. So in SI system of units, it is the power unit is watt. So then it is actually going on a horizontal road. So we can draw the situation that this is a horizontal road and this is the car. So it is moved from speed of 40 meters per second to a speed at a different location. When it reaches, its speed is 18 meters per second. So this one, assuming that there is no resistance to the motion. So there is no resistance to the motion. Calculate the time taken. So time taken we have to find. If we get the acceleration, time taken v is equal to 2 plus 80. Okay, so we have the power, or we can use the power method. Here we use the power. This question is not simple. If we find this work done by a driving force by using the work energy equation. Okay, so in those cases where the other methods are not fails to do this question, so then we use the work energy equation. So using the work energy equation, we can easily find the work done by the driving force. Okay, so work energy equation. Okay, so which means that the work done by the forward forces minus the work done against the backward force is equal to change in kinetic energy plus change in gravitational potential energy. Okay, so since this is the work done by the driving force, we write it as this thing we are finding, minus, since there is no resistive force, so this work done will be 0, and this will be equal to the change in kinetic energy, which is half into mass of the object into the final speed square minus the initial speed square. And then since it is going horizontally on the ground level, so the change in potential energy will be 0. So see that easy, we have found the work done by the driving force by using the work energy equation. Joule is the work done by the driving force. Okay, so therefore easily we can find the time by using this formula. So power is 25,000. That is equal to the work done by the driving force, which is 60800 divided by the time taken. So it means time is equal to 60800 divided by 25000. Taking t there and bringing this here. So it is 60800 divided by 25,000. So it is 2.432 seconds. So either you can write this because it is exact, or you can write it to 3 significant figures. So 2.43 second is utilized to increase the speed from 14 to 18 meters per second if there is no resistance or no other resistive forces, and the engine is working at a rate of 25 kilowatt. Okay, so see that this where it is clear that we cannot use Newton's second law here. It has 2 reasons. One is that we are not sure that the driving force is constant or not. Newton's second law is valid only for the constant forces. And it's clear that the driving force is changing. Why it's clear it's the driving force is changing? Because we know that this formula, through this formula, the driving force is equal to power divided by the speed. So if this is stage A and this is stage B, so at stage A, driving force is equal to 25,000 divided by 14, and at stage B the driving force is 25,000 divided by 18. So it means now we have a smaller driving force here. So that's why Newton's second law will not be applicable. We can apply the Newton's second law at one particular point but not throughout the motion. And since we have to find the time for the whole motion, so that's why by using Newton's second law we cannot do this question. Okay, we know that the power is equal to force times the speed. So this is just 2 minutes, I will take more. So power is equal to force times the speed. So 3 quantities are there. We know that if power is constant, if this is constant, then this might be constant, so then this must be constant, because constant time constant is a constant. And sometimes we have the situation that power is constant but the speed is variable. So it means variable multiplied by a constant cannot be a constant. So variable must be multiplied with a variable. Then we have the chance that the product is a constant quantity. Like if the speed is increasing, so with the same rate the force is decreasing, so then the product will be the same. Like 8 times 1 is 8. If the speed is 2, then the force must be 4. If the speed is 4, then the force must be 2. And if the speed is 8, then the force must be 1. So see, it's a variable speed and a variable force. So which means that two variable quantities, when we take the product of these two, so the result is a constant power. Okay. So in this example we have this situation, that speed is increasing, then the drive force is decreasing, so their product is a constant quantity, because in the question statement they said clearly that power is constant. Okay. So otherwise, if power is constant, then both must be constant if they are not variable. So this kind of situation will be involved here. One more important point is that when we apply the force formula, the work formula, work is equal to force times the distance moved. So here this force must always be a constant quantity. If the force is variable, then we cannot find the work done by using this formula. So what we will do in the case when we have to find the work done by any force when it's variable, so then we will use the power formula. So work done by the driving force divided by the time taken is the power. So it means work done by the driving force, even if it is not constant, so we can apply that it is P multiplied by T. Okay, so this formula will be used if if T is not constant. If driving force T is not constant. Okay, so this is very important, because in the past paper we'll see such situations where they will check the ability of the students that they have this concept or not. They gave us a variable force, and then the student, if they use the work energy equation, work done by the driving force and distance, that will be wrong. So then we have to use this formula in that case. So this is only for the constant force F. Newton's second law, forward force minus backward force is equal to ma. Here both the forces, this force and this force, must be constant. If not constant, then we cannot apply Newton's second law. Okay, so now I hope it's all clear to you.